CH3, oxygen, C2H5, methyl group, ethyl group. Its name is ethyl methyl ether, or this is also known as methoxyethane. Two different alkyl groups. Based on this matter, this is a kind of mixed ether. In this lesson, we are going to learn reactions of mixed ether. So let's begin. Mixed ether, CH3, oxygen, C2H5. When this mixed ether, methoxyethane, is treated with hydroiodic or hydrobromic acid, and the reaction is conducted in cold condition, then we get methyl iodide, that is, methyl group takes iodide ion, and another compound we get, this is ethanol. So when mixed ether, methoxyethane, is treated with hydroiodic acid in cold condition, then we get methyl iodide and ethanol. But when this is treated with excess hydroiodic acid, and the reaction is conducted by heating, then we get methyl iodide, that is methyl with iodide ion, methyl iodide. At the same time, we get ethyl iodide, and water is formed as byproduct. So two kinds of reactions in two conditions. That is to say, methoxyethane forms methyl iodide and ethanol reacting with hydroiodic acid in cold condition, but methoxyethane forms methyl iodide, ethyl iodide, and water reacting with excess hydroiodic acid in hot condition. Now let us see mechanism of the reactions. First reaction is methoxyethane hydroiodic acid in cold condition. Then products are methyl iodide and ethanol. Let us see mechanism of the reaction. Step 1. Hydroiodic acid produces proton and iodide ion. Step 2. This proton combines with ether, that is, this ether is protonated with the lone pair electrons of oxygen, and as a result, this is formed coordinate covalent bond between oxygen and hydrogen, and oxygen becomes positive in charge. Step 3. Iodide ion and protonated ether oxygen is positive in charge. Because of this positive charge, electrons move towards this oxygen, and as a result this carbon becomes positive in charge. At the same time, this carbon gets positive in charge, partially positive in charge. That is why this iodide ion gets chance to attack this carbon and this carbon, but this carbon is linked up with B group. That is, this carbon is not attacked by iodide ion due to the steric hindrance. So iodide ion attacks easily this carbon. At the same time, carbon oxygen bond experiences heterolytic fission. That is, here nucleophilic substitution occurs. Nucleophilic substitution. Nucleophile attacks this methyl group carbon to form methyl iodide, and after breaking carbon oxygen bond, ethanol is formed, which is a kind of neutral nucleophile. That is, nucleophilic substitution occurs. So when methoxyethane is treated with hydroiodic acid in cold condition, then we get methyl iodide and ethanol through nucleophilic substitution. Now let us see mechanism of another reaction. Methoxyethane, when it is treated with excess hydroiodic acid or hydrobromic acid, and the reaction is conducted by heating, then this is obtained: methyl iodide, ethyl iodide, and water. Let us see mechanism of the reaction. Step 1. Hydroiodic acid ionizes to proton and iodide ion. Step 2. Proton combines with ether. Excess protons. Due to excess protons, protonation occurs in this way. Ether. Double positive charge over oxygen. Excess protons combine with ether to form protonated ether with the two lone pairs of electrons of oxygen. This is formed. Now, this protonated ether because of this positive charge over oxygen, this carbon, methyl group carbon, becomes positive in charge because electrons move towards oxygen. Electrons move towards oxygen. Over this carbon, positive charge develops, partial positive charge. So, iodide ion, excess iodide ion attacks this carbon, at the same time this carbon, to form this compound, methyl iodide. When methyl group carbon is attacked by iodide ion, then carbon oxygen bond suffers heterolytic fission to form methyl iodide, and At the same time, when ethyl group carbon is attacked by another iodide ion, then this oxygen carbon bond suffers heterolytic fission. As a result, ethyl iodide is formed and water gets free as byproduct. So, when mixed ether is treated with excess hydroiodic acid and the reaction is conducted by heating, then methyl iodide, ethyl iodide and water are formed. This reaction cannot be occurred by hydrochloric acid. Hydrochloric acid is comparatively weak acid than hydrobromic acid and hydroiodic acid, and chloride ion is comparatively weak nucleophile than bromide ion and then iodide ion. So hydrochloric acid is not used in this reaction. This is all about reactions of mixed ether. Thank you very much.